Hello, Mr. Rana, right? Okay, so the first number is, let's say we have n. N starts with 1. When n is 1, we return 0. When n is 2, we return 0, 1. When n is 3, we return 0, 1, 1, 0. When n is 4, we return 0, 1, 1, 0, 1, 0, 0, 1. Okay, and so on. Do you find the pattern? What happens here?
Oh, it just reverses it, and it just copies it and then reverses it.
Good catch, okay? Good catch. I'm not quite sure if it's 100% like that, but it looks like this way, okay? Let me keep writing, okay? 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 1, 0. Is it copied and reversed?
Yeah. So it just acts. It copies it many times, and then it goes like 0, 1, 1, 0, 1, 0, 0, 1.
Okay, so I already give you the hint.
It just replaces the 1 with 0.
Yeah, replace. That's a good one. I replace 0 with 0, 1. I replace 1 with 1, 0. Replace 0 to 0, 1. 1 to 1, 0. And it looks like, I copy it and reverse. But yeah, parallel in mind. Reverse is very important. It looks like the second half is the reverse of the first half, right?
Yeah.
Okay, so the question is that we are given this nth row, and we're given another k. We want to find out the digit at nth row and kth digit at nth row. For example, like n equals 5, k equals 3. We need to return. This is 5, right? This is 5. But return 1, 2, 3. You need to tell me it's 1. Okay? We're writing these first few numbers and then we find out the pattern. So what's the pattern? So how many numbers on the first row? That's one number. How many numbers on the second row? 2 number. How many numbers on the third row? 4 number. And then that's 8 numbers, 16 numbers. So every time we doubles it, right? So if n, given the n, 2 to the power of n minus 1. 2 to the power of n minus 1. This is the number of digits for that row, right? For example, n equals 3. n equals 3. How many numbers? Is 2 to the power of 3 minus 1. Is 2 to the power of 2 equals 4. Okay? Any idea how do we find out how do we find out, given n and k, how do we find out? For example, like if I give you like n equals 4 and k equals 4, you should tell me is 0 because n equals 4 is here. And k equals 4. 1, 2, 3, 4. You need to tell me is 0.
I feel like there's going to be like some pattern without,
Pattern, yes.
Yeah, without like going through.
That's right, yes.
Up
Yeah.
to k.
But we can do a very straightforward, naive way, which is, because we know how to get to here, right, from the first row, right? Okay, so for example, I want to reach the 5th row. I can just do the first, second, third, and because
The first row is always on the first. That line is always 0 because on that left.
That's right, yes.
It's always 0, and then after that it was 1.
That's right, yes. And do you notice anything? Look, the first view. Do you notice? It's always the same, right? The prefix is the same. Do you see it? The prefix is the same. Yeah, if we write it in the triangle way, 0, 0, 1. What's next? 0, 1, 1, 0. And what's next? 0, 1, 1, 0, 1, 0, 0, 1. You see? This is the prefix is the same.
Because the first one is a 0, returns a 0, 1, and then the 0, 1 starts with a 0, so it's 0, 1, and then it keeps on going.
You're saying, right? Look, if I want to move from this row to the I want to generate a new row.
Just look at this is 0 and the 0, 1. So when 0 turns to 0, 1 and the 0, 1 bit is just a duplicate, but 0, 1 starts with a 0. So
Yeah, true. Look, you said that reverse, right? So I want to generate the content for the new row. I just copy what I have. This stays the same. Invert it, reverse it, right? It's not reverse. It's like is it reverse? It's not reverse. It's invert, right? It's not reverse. So here So I write it 0, 1, 1, 0, 1, 0, 0, 1. But I need to revert it. So 0 becomes 1, 1 becomes 0. Okay? Yeah, it's not revert, it's invert. Okay, and then the same goes back, copy, and then this bit, invert. Okay, so we know the process to getting to the nth row. Then we can do this. There's a quicker way to do it. Let me write that code first. Define f and k. If n equal 1 or k equal 1, then return 0, right? Okay. Actually, if we want to, if we want to do this in a naive way, we need to make it return a string, right? Then we can say the previous one, the previous equals the previous. We don't need a k, right? We can write it this way. Let me rewrite it, okay? Define fn. We want to find out the nth row. So if n equal 1, then we need to return 0, right? So the previous equals fn minus 1. So based on the previous row, we know, right? The current row is answer. Answer equals the empty, and then we need to go through the previous. For I in previous, then if I equal 0, then answer plus equal 0, 1. Else answer plus equal 1, 0. Right? So this is just the process of replacing 0 with 0, 1 and 1 with 1, 0. And then return answer. Okay, one quicker implementation is instead of using the string concatenation, we use the array, and then we just put this, append it to an array and return join, empty string dot join, right? Okay, so now once we have this f function, we can just return f n, and then we want the case, so the case which is k, right? Okay. However, this is not very efficient because in order to find the nth row, we need to go from the first row, second row, third row. We need to iterate over the, we need to iterate from the first row up to nth row and then find it. Yeah? Basically, we are constructing the string in the nth row. Okay, so this is not very efficient. The previous row, right? Because in order to generate, we know that when we generate the nth row based on n, is based on n minus 1. So for example, if n minus 1 is 0, 1, 1, 0, how do we generate the next content? We just take this, replace 0 with 0, 1, replace 1 with 1, 0, yeah? This is what it does, right? I get the previous row, I iterate over the previous. If it's 0, it's 0, 1. If it's 1, it's 1, 0. And then I construct this using the recursion, okay? Okay, so this is one way. Another way is, yeah, any question?
So you can, like, if you look up a previous row and then you solve a 0 to 1, then 1 to 0.
Okay, very close. Okay, so yes.
And then you just copy that part and onto the.
That's right. Yes, that's what I'm going to talk about now. So we don't actually need to generate a whole string, right? So instead, but we need to find out if it's in the first half or second half, right? Okay, so let's say if it's on the first half, if I want to find this bit, it's on the first half, what value is it? It's equal to this one, yeah? Because it's the first half, I can just reduce, this is fnk, right? If this is fnk, and if this k is on the first half, and I can just simply recursive go into fn minus 1k. Am I right? Yes? Now, what's the point of, moving from fnk to fn minus 1k? We're reducing the n recursion, right? This is the big N. I reduce it to n minus 1. And n minus 1 can reduce to n minus 1, n minus until f1. Okay? But how about if it's on the second half? So if it's, for example, if it's this one, how can we map to this fn minus 1?
You can do fn minus 1.
Okay, so for example, like if I want to get this value, the half is here, right? Let's look at this row, okay? Half is 4, but if I want to get this value, 0. So fn minus 1, obviously, It doesn't have this content. So how can I map to fn minus 1?
You just switch the ones with zeros and the zeros with ones.
Well done. So look here, right? It doesn't have it. That's fine. So this corresponds to this value, right? And I just need to reverse. Not reverse, invert it. So it's basically fn minus 1, k minus the middle, okay? And then you need to revert it, invert it, okay? Does it make sense? Okay, so let's say here we given this n and k, and then k, obviously it should be in the range, right? You're not saying n and k here, somewhere here, because it's meaningless. So if k is bigger than if k is bigger than the number of the digits on that row, k is bigger than 2 to the power of n minus 1, then we need to return empty or anything. Okay, so that for simplicity, we just assume k is smaller or equal than 2 to the power of n minus 1. Okay, yeah, so it's always stay in the range. So based on this, right, if we need to calculate the number of digits on that row and half, right, 50%, and then we need to compare k. If k is smaller than if k stays on the first half, then we can simply reduce it to fn minus 1k. If it's on the second half, then we can still map to fn minus 1, but we need to map to the first half, but obviously this is inverted. We can write this using the recursion as well. So define f and k. If n equal 1 or k equal 1, return. If n equal 1, k equal 1, return 0. Okay, good job. Okay, so now how many digits on the row? We talk about that. It's 2 to the power of n minus 1, right? So total equals 2 to the power of n minus 1. So how do we implement the power? In Python, we can use 2 star n minus 1. This is one way. Or we can use the mass power. This is a function, the base 2 and n minus 1. Or we can shift, right? So look, 2 to the power of 2. 2 to the power of 2, right? So in binary, this is 1. 2 to the power of 2 is basically putting 2 0, right? Putting 2 0 at the end, so it's 1 shifter 2, right? This is 2 to the power of 2, okay? So, yeah, we find out the number of digits on the nth row, and then half of it is t divided by 2, right? Yeah? Yeah. For example, there are 4 digits on the third row, half of it is 2 digits. Now we need to check. If k is smaller or equal than half, if it's on the first half, then we return fn minus 1k, right? Okay, then if it's on the second half, then return fn minus 1 k minus half, but we need to make it the opposite, not or 1 minus it, okay? Make sense? We are not solving this problem in one go, right? For example, like you ask me to find out the value of this. I'm not telling you how to find out it. I'm just telling you, okay, so if you know this value, fn minus 1, I can tell you how to get the value of fn from fn minus 1. So this is recursion, right? So why recursion is very powerful? Because we're solving the problem one step at a time. Okay? Instead of solving the fn, I'm not talking about how to solve this fn, but I'm assuming you can give me the answer for fn minus 1. And for fn minus 1, I can tell you how to solve fn minus 2. Fn. Okay, for example, like n factorial, we talk about this. 3 factorial equals 3 times 2 times 1, right? 100 factorial equals 100 times 99 times 98 times 97 tier 1, right? Okay? So f100, 100 factorial, right? 100 factorial could be very big, but how do you solve it? It's hard, right? So, but I know.
Get a calculator.
I know, but what I know is it equals 100 times 99 factorial. You see? And 99 factorial is 99 times 98 factorial. Okay? Same thing. So fn equals n times fn minus 1. Okay, and this fn minus 1 equals n minus 1 times fn minus 2. And this goes on until f1. When it's f1, I already know it. I don't need to calculate. f1, 1 factorial is 1, right? Once this is 1, and then let's go back to solve the f2. Go back to f3, f4, until, it's like this way. So this is the same. F and k, I can tell you fn minus 1. And then when you recursively call it until f1, right here, we know is 0. Okay? So we have to define a base condition for the recursion. Otherwise, if we don't specify this, what happens? The problem never gets solved, right? It's the same thing. F100. Okay, I tell you, F100 is F99. 100 times F99. F99 is 99 times F98. And this goes on until F1. But you're not telling me F1 equals what? And I can keep recursively calling F1 equals 1 times F0. And F0 equals 0 times F minus 1. Okay? Yeah, makes sense? And this goes on. Alright? Recursion, we need the base case to solve the basic. Okay, so to sum up, we want to find out the f and k. And based on the pattern, we know if this k is on the first half, right? Because each row, we know the total number of the digit is 2 to the power of n minus 1. It's always the power of 2, right? If the first one is 1, the next row is 2. There are 2 digits on the second row, 4 digits on the third row, and 8 goes on, right? So if k is on the first half, it's the same as the previous row, right? It doesn't change. But if it's on the second half, we need to map it to the first half, but invert it. Am I right? Does it make sense? You see, you see, right? Copy. So what are we doing? Duplicate. Put it here, but the second half needs to invert it. Okay? So if k is on the first half, we can simply map to the previous row. But it's on the second half, we need to, what do we need to do? Map here. Once we get it, once we get this is 1, then this value must be 0, right? Because this is opposite. What's the time complexity? Fn needs to do fn minus 1, right? How many rows? If there are n rows, every time I jump to the previous row, so it's actually all n. Okay, so what have you learned today? That's it. What have you learned?
I learned about this, how we have the 0 at the start, and we want to change the 0 to 0, 1 to 1 0.
Yeah.
And then we want to return k. Right?
Yeah. We want to return the digit at nth row and case. Okay. Yeah. So how many ways we talk about here?
3.
Why is it 3?
2.
Okay. What's the third one? Which method is efficient?
The last one.
The last one.
Of course it is.
Okay. Okay. That's it for today. Bye bye. Bye bye.
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 I say bye.